Hi everyone, my name is Siobhan Romita, and I'm here today to present to you my disorder, Biotinidase Deficiency. Let's get started. So what is biotinidase deficiency? Well, it is a very rare autosomal recessive disorder in where the body is unable to recycle the biotin that's in the system. This disorder is inherited from parents of the child. So why is it important? Well, this enzyme is super essential for recycling biotin that's already in our system. So what is biotin then? So most of us may think of biotin as that supplement that we would take to help our skin or hair or our nails. But biotin is actually more than just that. Biotin really helps our body break down proteins and fats and carbohydrates so it can actually help promote other parts of our body to function. So where is it found? Well, biotinidase is actually found in our blood. And so that is how they actually test to see if you are deficient in that specific gene. So who does it exactly affect? Well, typically it affects younger individuals under the age of 5, but not limited to just them, and specifically mostly infants. So when is this tested? So after a baby is born, they usually are getting tested for lots of different things, but specifically they usually get like a heel prick, and that couple drops of blood helps them test for several different disorders that they may have. So within the first few days of their lives, they get this test done, and it usually presents and shows if they are actually deficient in the biotinidase gene. So why is biotin important? Well, biotin, like I said earlier, goes way beyond helping just your hair and your skin. It promotes healthy eyes, nerves, and a very important organ in our system, our liver. So where can we find biotin besides a supplement? Well, it's found in lots of various foods, such as carrots and eggs, fish, lots of different types of beans, different types of cheeses, and of course, avocado. So what actually causes this gene to be deficient? Well, what happens with the biotinidase gene, there's a mutation in it. And this mutation is located on the 3p25 chromosome, and it consists of 4 exons with a total length of 1,629 base pairs. So there are 2 different types of biotinidase deficiency. There's profound, and then there's partial. With profound, it is more severe and the symptoms are a little more intense. You'll experience breathing problems, and the individual could have seizures, vision issues, and typically have a loss of balance in their movement, and also experience alopecia and different types of hair loss. And this actually, the profound affects less than 10% of the enzyme deficiency. That's how they know that someone is diagnosed with profound BTD, because less than 10% of activity is found in the enzyme, where with partial it's more 10 to 30%. So that's why it's considered less severe, and the symptoms tend to be less severe as well. They still experience different types of skin rashes and also hair loss and hypotonia, which is loss of movement with like muscles and being able to, keep their neck up and their body up. So what is the mode of inheritance? Like I said in the beginning of the presentation, it is an autosomal recessive pattern, and healthy carriers of this condition typically have one normal gene and then one abnormal gene. So for example, if a carrier parent has a 25% chance of having a child that has 2 copies one of being an abnormal gene and another, for example, an abnormal gene, which would result in the BTD deficiency. So also, in addition to that, parents have a 50% chance of having a child who does not suffer from the disorder, and another 25% chance having the disorder if they're unaffected, and also a non-carrier child, so they don't carry this recessive gene. But if they do have a child that happens to have biotinidase deficiency, it is a very good idea that all the siblings that are tested from a genetics counselor or anything like that, just to make sure that they don't have that condition in their system. So here is my pedigree that shows just some examples of how this autosomal recessive disorder goes. With the circles that have no shadedness, that is a normal individual. And then if the circle is fully shaded, that means that they have the condition. And then if there's a partial shade, that is showing that they are a carrier of the disorder. So what are some options for genetic testing? Well, there's lots of different ways people can get tested for biotinidase deficiency. Some examples include a targeted mutation analysis, and this is going to really help identify specific parts of the genetic code that they are going to test directly for. Also, they may want to pursue complete gene sequencing or deletion analysis. I would definitely recommend them seeking a genetic counseling service company where they can test the entire family and really be able to break down the genes to see if there's any mutations, and also prepare the family, if they are carriers, for treatment, and also educate them. So in conclusion, deficiency of this enzyme leads to having the biotin in your system not able to get recycled. So what happens is there is a shortage of compounds and they start to build up in the body, which then, as they continue to build up, they start damaging and affecting various tissues and cells. So this is why this is just so important that you have like early detection, because these mutations can lead to some serious health concerns. Here are my references for my biotinidase deficiency presentation. I hope you enjoyed it. Thank you. Bye-bye.